Chapter 3, Building Original Templates. $20, starting in 5, 4, 3, 2, 1 now. Chapter 3, Building Original Template. In this chapter, we learn about determining when to create a template, understanding the elements of a good plate design, developing a basic math template, creating a structured template, defining a class template, using templates, some template specialization to your advantage, and building a library of templates and using your custom built template libraries. This is the goal right here for what I would like to do for when I start coding is template libraries. C++ that I make. C++ has been around for many years. Because of its longevity, C++ templates abound. In fact, it may seem that there is a template for every practical purpose. However, the templates that are available to the developer community through standardized and third-party resources usually reflect generalized needs. The individual company you work for, or you as a developer, may have specialized needs that a generalized template can't address. Remember, every programming tool in existence offers a certain amount of flexibility. The reason why you see so many generalized tools is that someone developed them and the community as a whole decided to adopt them. Never think that you can't create your own tools. After all, someone created the generalized tools you work with daily. Creating a custom tool requires nothing special, just time and thought on your part. The trick to creating a customized tool is to think the process through, just as you would for any application you create. The fact that you'll use this customized tool to create multiple applications means that you must apply a higher standard to its design and the code it contains than you would for one-time applications. A mistake in a customized tool can spell errors in every application you create using it, so this code must work well. This chapter addresses the thought process behind templates first, and then shows some typical template examples. The examples will help to demonstrate ways in which you can use templates to create better applications that require less code because the templates you create meet your needs more completely than any generalized template can. After you see the template examples, you discover the techniques used to place a number of templates in a library. Finally, you discover how to use a template library to create applications. Yes, that is the goal. Yay. Deciding when to create a template. The first step in creating a template is deciding whether your idea will generate a useful template. Most developers have thousands of creative thoughts that translate into ideas during their careers. However, only a few of these ideas are exceptionally useful. By determining whether the template you want to create is a good idea at the outset, you waste less time on bad ideas and have more time to create that truly useful idea that will help you ascend to the pinnacle of development notoriety and the astronomical amount of cash that such a vision tends to generate. Before you begin creating the next template to awe and inspire developers everywhere, consider the following questions. Is there a generic template that is close enough to meet your needs? A good template idea is unique. It does something more than perform a useful task. It performs a new kind of useful task. Template ideas that fail the uniqueness test usually consume many resources for a small payoff. Will you use the template more than once? Some template ideas are so tuned to a particular project, the developer ends up using them precisely once, which means that the template never provides a payback on the investment to create it. Will the template save more time than you used to create it? Templates can become complex. In fact, some templates are complex enough that you'd save time by not writing them at all. The reason to use templates is to save time and effort. So a complex template tends to require a larger payback period than a simple one. Is there a third-party template you can buy, or better yet, obtain free, that nearly meets your need? Someone else may have already had your good idea. Before you invest time in creating a template, you should spend time researching online. Someone else may have created a template that nearly matches your idea. Obtaining a third-party template that's close to what you want is always more time efficient than creating a custom template on your own. How generic is the template you want to create? Many good template ideas are simply too specific, which limits their adaptability to other situations. You want to create a unique template, but a unique template that can meet a range of organizational needs. Is your template concept complete? Developers often envision only a piece of the template. For example, if you create a math template, you should actually create a library that contains all the equations you plan to use with your applications. Designing a template that contains a single equation is never worthwhile because other developers will have to finish the work you started. Do you have the skills to create the template? Not everyone is a good template designer. A template designer must define a template that goes beyond the original expectations because someone will always certainly use the template in unexpected ways. The best templates adapt to new situations that the originator never considered. Consequently, creating a template requires a different sort of mindset than creating an application. Remember, a little research at the outset can save significant time, effort, and replicated development. C++ has been around for a long time, at least in computer terms, so you can choose from a wealth of existing code. Always determine in advance whether the template you want to create is worth the effort and will make life easier for other developers. That's good to know. Remember, this is a reading of C++ On for Dummies. This is the third edition. This is written by John Paul Mueller and Jeff Cogswell. Defining the elements of a good template. Book 4, Chapter 5 provides you with some insights into basic template creation techniques. However, this introductory chapter doesn't address what makes for a good template. After all, you don't want to appear like the guy who builds in his garage. The template you create has to look professional and work as expected. The first decision you have to make is what kind of template to create. You can choose among these three types. Function. A function represents the simplest way to create a template and eases debugging requirements. You can group functions in libraries to make them easier to access. However, functions often lack depth, and you can't coordinate activities between them as easily as you can between the elements of an object. Structure. A structure provides the best speed in many cases and can reduce the amount of system resources required, depending on how you define the structure. Remember that C++ allocates memory for the entire structure, but structures also present opportunities for optimization that you don't get with a class. Oh, that's good to know. Hi, Ryan and Gina. I'm going to eat just after I do this. Class. A class provides the greatest flexibility because you can express the template using all the elements that a class can provide. Methods, properties, and events. You can inherit classes to create new classes. In short, if you have a complex idea to implement, classes are the way to do it. The second decision you have to make is how to weight design factors when creating the template. C++ offers myriad ways to accomplish any given task. For example, you have multiple ways to create a function. However, one method is normally superior to the others simply because it offers some particular benefit. Consider these requirements when choosing the kind of template to create. Security. Simplicity often translates into easier to secure. In general, functions are easier to secure than structures, which are easier to secure than classes. However, you can easily write an insecure class if you use the wrong approach. Secure templates often require additional checks that can affect reliability. The template tends not to allow specific actions when these actions affect security and speed. Additional code always slows template execution. Reliability. The options you choose will affect the reliability of the template you create. A reliable template produces consistent results for any data types applied to it. In some cases, ensuring reliability means adding checks to the template, which increases complexity. The additional code affects both the security and the speed of the template. Speed. Templates save the developer time. However, if the resulting template produces slow code, you can be sure that users will complain and the developer will end up rewriting some code to improve application speed. A fast template is usually small and performs the task precisely. The additional checks required to ensure secure and reliable operation always affect speed negatively, so you must work to achieve a balance. Usage. Some templates are so difficult to use that we doubt very much that even the originator uses them. If a developer can't determine how to use your template, no one will ever use it, and your effort is wasted. Consequently, you must design the template such that it meets security, reliability, and speed goals without becoming overly difficult to use. Time. Every time you design a new piece of software, there is a time element involved. It's essential to decide whether the template will ultimately save enough development time to offset the development costs of creating and testing it. A template that you only intend to use a few times may not be worth the effort. Maintenance. Someone will have to maintain the code used to create the template. A good template is one in which the code is relatively straightforward. Of course, you need to add comments to the code that explain how the code works and fully document the template design. Most templates see some level of redesign during their life cycles. They evolve as developers use the template and discover new ways to incorporate it into applications. Renadia said, I need to go back to the dentist again. I got 3 checks in the mail. That was twice the total of going. I think I found my new job. Are you saying you're trying to go? What? I'm a little confused. Was that a joke about you need to be going to the dentist or you need to be being a dentist? That one went right over my head. Remember, the best template is the one that seems obvious. We were recently reading an article about the invention of the safety pin. The safety pin seems obvious, but someone still had to invent it because no one else had thought about it. When you create a template and someone tells you that it seems like an obvious idea, don't get mad. Be glad. You join the ranks of people who thought of something that fulfills an obvious need, but no one thought about it before you did. Hi, Piran Prakashadari. Thank you so much for being here, and thank you for the like. And also for the welcome. The third decision you must make is how inclusive to make the template. In some cases, you want to create a template that can handle a range of situations. However, a template can quickly become unwieldy and difficult to manage. A good template is balanced. It includes the elements you need, but nothing beyond. Creating a basic math template. With a math template, you usually need access to a wealth of calculations, but may only use 1 or 2 of those calculations at a time. For example, if someone is calculating your mortgage, he or she doesn't need to know the amortization calculation. However, the person might need the amortization calculation when working with the next customer. In short, the calculations all have a purpose and you need them all, but you don't need them all at the same time. Because of the way you use math templates, they work best as a series of function templates. The math template example in Lesson 3-1 shows how to create the series of functions. Lesson 3-1, defining a series of function templates. Hashtag include IOStream, hashtag include CMath, using needs to be standard, template, type name T, T area, T height, T length, return, height times length, const double pi equals 4.0 times a tangent 1.0, template, type name T circle area, T radius, double result equals pi times radius. This version truncates the value, return T result, template, type name T triangle area, T base, T height, double result equals base times height times 0.5, result, T result. Listing 3-1 continued. Int main C out 4x4 areas in line, C out square area int 4, 4 in line, C out circle area int 2 in line, C out triangle area int 4, 4 in line, C out using a value of pi in line, return 0. The calculations could consist of any math calculation. The point of the example is that using functions makes each of the calculations discrete, easy to use, and easy to manage. When you run this example, you see the following output. Four by 4 areas, square 16, circle 12, triangle 8, using a value of pi of 3.14159. Note that circle area int 2 uses half the value of other calculations as input. That's because you calculate the area of a circle using the equation pi times r squared. If you want to see other area and volume equations, check out the website at http://www.aquatex.com/calculat.htm. Tip. For consistency, you could change the circle equation to read like this. Radius equals radius divided by 2. Result equals pi times radius times radius. That's kind of messing me up because I know radius is equal to okay, it's escaping me right now, but it's not the rate. It's not the radius times 2 is equal to the thing. What am I thinking of? What's the word that is escaping me right now? I think it's the diameter. Either way, yeah, diameter. That's weird. I wonder why they put it that way. Okay, divide the input by 2. As soon as you're changing the diameter. Ah, yeah, that's what it is. What? But then why didn't they just put in diameter? Whatever. Dividing the input by 2, essentially changing the diameter to a radius, means that you could call the equation using the same number as all the other area calculations. Circle area int 4. Whichever approach you choose, You need to document how the template works so the other developers know how to use it. You should also note that the circle and triangle calculations perform a bit of type coercion to ensure that the user gets the expected results back by modifying the return statement to read return T result. The type conversions are needed to keep your templates from generating warning messages. It's important to note that the approach used in the example triggers the result when the template runs an int. Okay, that's called time is up time. So we did pretty good, honestly. Hold on. We got to page, bottom of this page, 722. And the next chapter is going to start up at 737. So not bad for today. Renardine. I might be able to do an all-nighters, possible. Depends on how I feel. But at least right now, I gotta move on to the next thing, which is I need to eat dinner time. And then after that, I got to do at least 1 hour of Madden modding. And hopefully after that, I'll still feel like doing some Kingdom Hearts time. So we'll see. But for now, I'm gonna go ahead and close down the chat. Technically just close down the stream because I really need to go eat something. So hopefully you'll be available, Renardina, for whatever I do the rest of tonight after I eat dinner. So thank you, Renardina. Thank you, Brian Prakash Jaderi. Thank you, Chief, for being here. Even though you said literally no one was here, you were here. You were messaging. Kind of not literally no one here. Also, I'm here, so that doesn't mean that. I do have a lit degree, literature writing. I mean, I do have the computer science degree also now, but let's not forget, I do have a lit degree. Yo, hello, Gosh is cool. Gosh is cool. Yeah, well, food and cage, sure, but I still have to get the mountain modding in. Look, my boyfriend would really like his game, and I would really like to make sure my boyfriend is happy, so I'm gonna have to try and get that in. Yo, Gosh is cool. Gosh is cool. Well, maybe you'll come by later for whatever I do after I eat dinner. Gosh is cool. Gosh is cool. But I do have to get going now. But thank you for being here. Gosh is cool. Gosh is cool. Thank you, Nightbot. And thank you to anyone who might check this out in the future. Also, thank you to anyone who I may have missed. Got the order mixed up on that one. And whatever, whoever, however, whatever. Just make the most of it. That's the most important part. Bye-bye.